Hello students, good day. Uh, this is your first introduction chapter for this course. This chapter contains very basics of the course, the definitions, its description, how it fits in, what are the things that we can call operating systems, its various types, and it enables you to see the big picture, how the all thing fits in computer sciences. All right, to begin with, what is an operating system? Operating system is any program that sits between the user and the hardware, any type of program. For example, if you are driving a car, your steering, your gearbox, and your accelerator, brake, clutch, all of these things, they are your interface between the hardware present in the car and the user who is driving that car. So anything that provides you an interface between the user and the machine is an operating system. Likewise, if you are operating an air conditioner or for example multimedia. So the operating system can be the remote device that is provided to you. So the various buttons that are present in there, you can play with them, you can interact with the device through those buttons. So that is an operating system for you for that air conditioner. And same is the case with this multimedia projector. In exactly the same manner, when we talk about computers, an interface between the user and the hardwares present in your machine is an operating system. It provides you various tools through which you can interact with those hardwares. There is uh, sometimes they are efficient, sometimes they provide you fine-grained control over hardware. Sometimes it provides some abstraction and hides details about the working of the hardware and provide you a clean and understandable interface. So usually we have basic some basic goals of operating system. So mm, the first one is it execute user programs. When we talk about operating system of computers, so the first responsibility of operating system is to execute user program and make problem solving easier. Uh, when we say that execution of user programs, it can mean that there can be various aspects, various types of user programs, different problem solving ways and tools that a user can adopt to solve its daily life problems. So this a basic goal of operating system should be to provide a layer, to provide a platform where users can write down programs to solve their own problems. Not all the programs that are present right now, but any future program of their own choice. Second goal of operating system is that that is within the definition that it makes a communication between the user and the hardware convenient, and it provides you a way to handle those hardwares in an efficient manner. Mm, just like I gave you an example of a car and the driver. Through that example, in daily life, you can see that how you can be altogether ignorant of the what's going on in the car, about the hardware and how the tires are moving and how engine is working, but you can only learn how to operate on it through whatever interface is provided to you. A computer system may have some components that can be either used to enhance its functionality, or they can be the core components or basic components to aid its working. So it is possible that you have one or more processors. One is required. You are required to have one main memory, your RAM, uh, and then some permanent storage device is required, either in the form of hard disk, floppy device, CDs, or some disk. And then several other devices that can be plugged with the machine to achieve some functionality, external functionality. And then we have a wide range of input and output devices that can be used to get extra functionality from the machine. And if we have a software, if we have an interface that can be used to get benefit from all of these hardware, we will call it the operating system. So I believe up to this point in time, the basic definition, the basic concept behind the definition should be clear, that operating system is a tool that can be used to interact with the hardware. So here we have a diagram that elaborates how operating system fits in our perspective in computing systems. So over here at the bottom we have the hardware. It contains the processor, RAM, or any other devices that we interact with. You can see that it appears as a black box, so it is not required to have any deeper understanding of their functionality, their interaction, their components. We have another whole domain that deals with the working of and the interaction of these components, but not in this course. Mm, So over here we have this operating system. You are very well aware of several operating systems that are very common. Windows, we have Linux, we have several other. BSD is another very famous operating system used for educational purposes. It also provides a handbook for its functionality, so you can download it. It's BSD, uh, so you can utilize it, but actually it has various interesting components in detail for the implementation of operating system. So usually we have operating system sits on top of the hardware. We will talk about what's the kernel mod and what's the user mod probably after a couple of lectures, when we have a bit deeper understanding about this whole architecture. And then over here we have user interface. It can be some user program. It can be provided by the provided and packaged with the operating system, or some interface that is sometimes provided by the operating system, or sometimes written by the other by other users, by other companies. And on top of this we have all programs, like when you open up your browser or your presentation, you are actually using this user interface and operating system beneath it to work with the hardware that is present in there. So all programs like web browser, emails, music players, presentations, whatever falls in here. So the very same thing in detail. So we have hardware, that's the bottom layer. So it provides the resources to run the machine. So it has CPU, memory, IO devices. Then we have the operating system that sits on top of it, and it provides an interface to this hardware, and it's a intermediate layer between the hardware and the application. And then we have application program. You can see that over here in this operating system, from the previous slide, they had both of the interface as well as the OS. They are packaged together in the form of operating system. And then the third layer that was there in the previous diagram as the top layer, you have your different programs. We have word processors, PowerPoints, compilers, browsers. So everything is there in the application domain, application programs domain. And then we have users who are actually using this. Uh, they can be machines, other computers which are asking for the services, but right now we are not concerned about this much, because we know that machines or computers can request other computers to for some resources, like all of this cloud thing, all of this IoT domain. We know that machines interact with machines, but that is not the core problem for this course. In this course, we will be talking more about how this interface is provided to us to handle those hardwares and various components of that operating system package. All right. So here we have the very same diagram, and over here we have another elaboration of the very same thing. Okay, here we have multiple views about the operating system. As you can see, that as with everything, we have multiple angles to look at things. For instance, as a student, they can think about a course from a student's perspective. They can assume that the course will deliver them good knowledge. They will get good marks, and it may help them to get good understanding of the domain that helps them in real life, and that helps them in getting a good job and lead a good life. In the same manner, when a faculty or an instructor is looking at the same course, he looks that the the content are delivered in an easier manner, understandable manner, and they have to link it with the real life examples just to make sure that students can relate to this stuff, as well as he tries to compile the whole course in a way that that add some value to the knowledge of the domain of the students. Also, at the same time, he has to make sure that all the students, they are analyzed for their capabilities about the course, their understanding about the course as well. So he cannot treat everybody at the same level if there is a difference in their effort and their understanding. So if we look at things, anything, we have different perspective. So how you see them, in the exactly same manner, when we talk about operating system, uh, users look at them in different way, as well as developers, they have to look at them in entirely different way. So for instance, a user can look at things that it can be easy to use. This is just one angle of looking at this, easy to use. For example, a user might be maybe interested in the operating system should provide just a good way of accomplishing some task. He may not be interested in how that task is being done. For example, if you are working with a machine that provides you a vocal interface, and you can operate on on that machine through voice commands, maybe it requires more resources, and it's a bit slower compared to a machine where you can directly interact with the commands at least. However, because it provides an ease of use, so user may not be very concerned about the resource utilization or optimization or customization of that application. At the same time, it is also possible that some of the users, they are more interested in customization of commands. For instance, some of the users, they may be interested that the data packets in a web browser, they are not sent in a stream of bits, but rather in form of chunks. Uh, so a different protocol can be used for this communication, maybe a better secure protocol. In this way, they have more control over stuff. There are operating systems that provide you different types of customization. So for instance, if you want to print a page from the printer, Uh, one way can be that you provide it just a print command that it prints it for you. The other is you have various customization options, like you can print on both sides. You can print either on portrait form or landscape form, or there are various other ways in which you can handle the operations of the printer. So all of these depend on the user's expertise as well as how they look at things. So over here, for instance, we have user friendliness, we have customization, and we have stability. So if we are concerned about user friendliness and customization, we have Windows. Just like this, if we have stability, if we require stability and user friendliness, we have Mac operating system, and customization and stability, we have Linux operating system. Like for some of you who are already aware with multiple operating systems and they have worked on it, they know that for instance on Windows they can there is some customize that you can customize commands, but a lot of details are hidden from the user because they can be they can work in an ignorant fashion about what's going on in there. So their task can be done without having any detail about the working of the command and working of the machines. However, if you are a bit mm, you know exposed to Linux, you know that over there you can customize a command to a more fine level. So for instance, if you want to connect to an internet in Windows machine, you just have to provide the user ID and password, and that's all. Probably you need not to know about various configurations that are there on the network card. However, if you are configuring the very same thing on a Linux machine, you may have to provide a lot of other options that can help in several situations, but definitely that is not very user friendly, and it exposes you to a lot of options that a casual user may feel too much. All right. So when you are developing the very same operating system, you may think about various other things. So it is possible that you think about that how resources are utilized, how processes are managed, how memory is managed, how users are managed, and not only these four management, but there are several other things that developers of this operating system may be interested in. So they may be interested how how many processes should wait for one processor. So how a single process is actually managed, how it is divided, and we'll talk about this in chapter 3 in detail, how processes are managed and how it can be divided into multiple chunks called threads, how memory is managed. Memory means it can be your RAM, your main memory, and sometimes we also consider disk in it. But when we are considering the system view uh, of operating systems, memory means RAM. So in this course, we will be more concerned and will be more uh, focus towards the system view of operating system, because we are looking at things from a developer's perspective. So we will be more concerned about how processes are managed in a machine, because from the user point of view, all of you you will be already comfortable with the using operating system. So this course is purely from the perspective of this degree, that you know very well how things work in an operating system. So coming to the definition of operating system, we have various angles through which we can see this definition. As by the discussion so far, you may have analyzed that one thing, uh, it's an interface between the user and the machine. The second thing is it's a resource allocator that handles all the hardware resources for you, and it is responsible that those hardwares are used in an efficient way, and also it is responsible for the execution of user programs. Having said that, we have come to a very interesting definition, or a very interesting introduction about a component, that is the kernel. Kernel is the core of the operating system, the very core. So you can say that kernel is the operating system. Usually we have multiple routines, we have multiple services that are associated with the execution of multiple programs. They may or may not be used all the time, but they are there in the operating system package. But for example, they are not used all the time. However, kernel is something that is present in the RAM all the time. When we switch on our machine, this kernel has to be loaded onto your main memory, onto your RAM. Uh, we will consider this in a bit more depth after a while, when we have all the basic components in place. When we say that operating system is a resource manager, we mean that it handles all the resources, all the hardware of the computer in the best possible way. So when we say uh, this, we mean that if there are multiple processes, it should find a way that all of them should be given equal priority. There can be different variations to this, but if all of them are at the same priority level, it should give them a fair allocation of resources. So it should provide you a way where multiple programs can run at the same time. It is not simultaneously, but at the same time. For a fraction of a second, there can only be one program that is running in the machine. We will talk about it in detail after a couple of chapters, but at the moment, it should be enough for you to understand that multiple programs should be able to run uh, in parallel, or at the same time in a system. Also, it it should not let one program to interfere with any other program or any other device, which means that each program should execute without any interference from other programs. Again, definitely it depends on the perspective, the code, whether it requires or it allows other programs to communicate with it. We have various mechanisms to allow it, but at a general level we will talk about all of these details towards the mid and end of this course. But at the moment, the core, the basic functionality should be that two of the programs should not interfere in a negative manner, should not be able to interfere with each other. Also, operating system, I mean, this is a bit advanced thing, that operating system should allow multiplexing of resources, meaning that resources should be utilized or shared by multiple processes simultaneously or in the same time or in the same space. We will talk about this in detail, a lot of detail in third chapter and fourth chapter. Up to this point in time, this should be enough for you to understand that operating systems allow us to share the resources in real time. So these are some of the basic components of a simple computer. You can see various input and output devices, and you can see various hardware that are in there, and or actual task or actual goal in this course should be that how all of them interact with the user programs. Now let's discuss different important components of a processor. There are several important things that are considered when we push a process into the processor. The first one is the instruction set, which is the set of instructions that a processor can execute. Usually, a processor is defined by the instruction set that it supports. For example, a Pentium machine has its own unique instruction set, and a Spark machine has its own unique instruction set, and both of them are not compatible with each other. I hope that from your computer architecture course, you got some familiarity with the different instruction sets, so you may know why an object file compiled onto a Pentium machine cannot be transferred to another machine which does not share the same instruction set. The important point here is that the instruction set is a set of commands that a particular machine can execute. The other important component is the ALU, or arithmetic logic unit, which handles the execution flow of your programs. The next one is instruction register, or IR. This is a special purpose register that is used to store the address of the next instruction that you are going to execute. The other one is stack pointer. Uh, there is a special memory structure stack that holds the return address of functions and every component that is there in a program. So your stack pointer points to the top of that stack, and it can evaluate which was the calling process for this particular job in execution. Then there are set of general purpose registers that are there in the processor. Another important component is program status word. This is used to indicate various bits that are used to verify the comparison statement, whether something is less than the other,
greater than the other or equal to the other. So different bit codes are there for each of these statements. Then we have the pipeline. This is There are several ways in which this pipeline can be structured. A usual pipeline means the life cycle of an instruction, meaning that it can be fetched, decode, execute, and then stored. So this is a usual pipeline. However, this basic structure is refined to have multiple variants, and some of them are there onto the next slide. So over here we have example of different types of pipelines. You may have studied in other courses that this is a fetch, decode, and execute cycle. There is another component that is in there, that is the stored. So fetch, decode, execute, and store is the whole cycle, but usually the store is associated with the RAM, so that is why it is not mentioned in here. So the fetching of an instruction from the RAM, and the decoding of the instruction, and then execution of the instruction is there in a pipeline. On the other side, you have a superscalar CPU. Superscale CPU implements instruction level parallelism, which means that a single processor, it can execute uh, one more than one instructions in one cycle. In a usual the usual CPU, we have only one instruction execution during one cycle. However, when we have a superscalar CPU, we may have multiple instructions running in different components or different execution units on the processor. This definitely enhances the efficiency of the machine. So that is all for today. I hope that you are having a good time. So stay safe. That's all for today. Thank you, students.